Hello, welcome back to Mars. I'm Mick, we're playing Stationeers. Now I've had a couple of people ask me about bulk storage of items there, so I thought let's do a bit on bulk storage. Because of course, when it comes to keeping your base neat and tidy, I'm always the first person that comes to mind. So let's get stuck into it, shall we? Now when it comes to bulk storage, your two main items that you're going to be using here are your vending machine and your storage silo. Both of these come with their inherent advantages and disadvantages. In terms of power consumption, there's not a lot of difference here. We have the silo is using a whole 1 power and the vending machine is using 5 power. So they're not exactly power hogs in what you're trying to do. So that's not going to be much of a decider of which one you want to choose. In terms of storage capacity, you can see from your tooltip here, the silo can hold 600 items. Whereas our vending machine can hold 100. So in terms of actual ability to hold items, your storage silo is by far the better one to do. It takes up twice as much space, being 2 grids tall, but it still holds more per grid. So 300 per grid over 2 grids is 600. This holds 100 and fills 1 grid. So space-wise, this will store more. Power-wise, it's slightly better, but when it comes to retrieving the items from there, that's where your vending machine really starts to shine. Because this one is a first in, first out. So if you put in 10 items, the only way you can retrieve them is by pulling the lever and they come out. The first one that you put in, then your second one you put in. So if you want to retrieve the 10th item you put in, you've got to pull out the first 9 to get to the 10th one and then put the other 9 back in again. So all it will really tell you is how many items are in there. It won't tell you what's in there or how many's in each stack, because when things go into here, they kind of cease to exist until they pop out again. So if you've got multiple items in there, it's probably not the best one to do. You can use it, but you've got to pull items out one at a time and have a look at them. Whereas this one, if we look in our thing here, look up our vending machine. Come on, vending machine, there we go. We see each item has its own slot. There's 100 slots in there, one for each item. So for each item that's in there, you can then check what it is, how many's in each one, the condition, and what each one is. So you can then sort of write some code to actually tell you exactly what's in there and retrieve any of them at will, because it has a request hash item there that you can just send to it through the logic and it will retrieve whatever you want, or you can just flick through the controls there and pull out whatever item you want. So
power low.
If we have something in there, we have our items, we can just select from it and just vend out whichever one we want. Whereas the other one, we put stuff in there, we just know there's one item in there. We've got no idea what it is. And to eject it, out she comes. So that's what we've got there. So let's actually see what we can do with them in terms of actually using them for storage. Now, if we're going to retrieve something from our silo, first thing we have to do is set up a way of specifying what we want to retrieve. Now, for demonstration here, we're just going to be using ores. So we shall make up a dial and use that to select some ores. Now, the dial will just select a number, and I mean, you can just use a number if you've got a heap of silos there with sorted stuff in it. You just want a number, then you use that number to decide which silo obeys the command. But if we've got mixed things in there, we're actually looking for an item, not an actual silo number. So that will be our first go here. So we've got a dial, and we shall read that and assign a prefab hash based on whatever number selected there. So here's a little script I've got for doing this. Now I have done this before in one of my programming tutorials. What we've got here, we've just got the dial set up to D0. I've assigned a register prefab, which is going to where we're going to store the prefab hash for the device we're looking for. So once we start, we load into our temporary variable R0 the setting from the dial. Now we're going to use a relative jump to choose what our prefab hash, so we don't want a 0 value because that will just mess up this relative jump. It'll just keep jumping back to the same spot and never go anywhere. So we're adding 1. So 0 becomes 1, 1 becomes 2, etc., etc. So that's what we've got. Now we set our prefab to 0. This is important here because we're using a select command to decide what we're doing. Now then we do a relative jump. So if we've got, say, 2 set on the dial, we add 1, it goes to 3. So relative jump, 1, 2, 3. It'll get to this command first. So what this does, we've got select. Select what we're going to set is prefab based on our deciding variable, which is also prefab, which makes it look a bit confusing. Now if prefab is 0, it'll take the second number. If prefab is not 0, it'll take the first number. Well, the first number we have is actually still prefab. So if prefab is 0, assign a new number to it. If it's not 0, keep the old value and put it back into here. So once it's done that, it'll move on to the next line. Then prefab is not 0, so keep the same value, and on. So keep the same value, keep the same value. So whichever one it steps into first, with the prefab 0, it'll take that hash value. Then get it all the way down to the end. It'll retain that same value all the way to the end, and then it's just setting it to the prefab housing. So if we confirm that one, export it into our chip, I shall need to put our dial in there, switch it on, we're good. And our prefab hash will change based on what we put in here. Now it's just assigned to the housing there. It's not much good sitting on the housing here, but we do have a hash display over here which we can connect to the IC housing, and if we yoink you out, it'll shows us a picture representation of it. So I'm just using ores there, but you can use any prefab hash of any device you like. So now as I flick through that, I get a picture of whatever piece of ore we've selected there. So now that we've got a prefab hash of what we're looking for, we need a way of actually now comparing it with what's in the silo. And we can't actually compare it with what's in the silo, so we're going to have to actually eject them one at a time into a sorter where we can compare them. If it's the right item, we'll pop it out here. If it's the wrong item, we'll put it into a chute where it'll go round the back and back into there. I, of course, don't have that one hooked up there, so we can just see things coming out. Now the plan is we shall set what we want from our dial. We shall pull the lever to get it started, and it shall then cycle through all the items until it finds what we're looking for, or just doesn't find what we're looking for. Rightio, so a bit of more coding. So what we have here is we've put in our silo with our dial, sorter and our lever. Once again, we've still got our prefab hash. We set our sorter into mode 2, which allows it to be controlled by the logic, which is what we're doing. We still have our same code there just for selecting our prefab hash from the dial. What we've added down the bottom here is we check the lever to see if it's open. Right, we immediately save that into the silo. So if the lever opens, the silo opens. That's good. Now we load from the sorter, from slot 0, which is your input slot, what is in there. What's the occupant hash of what's actually in the sorter? Assign it to R0. If R0 is equal to our prefab that we selected from the dial, we'll set it to output 1. Otherwise, if it doesn't match, it goes to output 0, which returns back to there. So if it hasn't found, go back to the start, do it again. If it has found it, we'll just close the lever, close the silo, and we're done to get good to go again. Now, so should confirm that, export it, we're good. So now we're looking for gold. I've only got 2 items in there. I don't know which one's first, but let's go. So if I pull the lever, it goes. Didn't like that one, that's copper, and boom, there's our gold. It's found the gold, let's switch the switch back off again. So there's a simple way, well, relatively simple way of actually retrieving an item from a mixed item in the bag there, but it does have its drawback because you don't actually know what's in there. I might be looking for gold, but I don't know if there's actually any gold in there. And if there's 600 items in there and it searches through one per second, that's 10 minutes it takes to search through the whole stack of whatever's in there. So while you can use that to sort a mixed bag of items in there, it's probably not the best way to do it. In terms of storing things, as I say, that's brilliant. In terms of retrieving things, this is the way to do it. So let's try the same thing on this one, shall we? A slightly different program, but will be good. Right, now for this one, we're going to swap out our lever and we'll just replace it with a button, because we're just going to pick our item, press the button to request it, and it'll be that simple. Now the code for this one is actually a lot simpler, because we just need our vending machine, our dial and our button. Once again, the dial is just there to select our same bit of code there, which just selects the prefab hash based on the dial setting. Now the code to actually do the rest of it, it's actually a single line of code. The other two lines there are just to check the button and see if it's been pressed. So just load the button setting into R0. If R0 is equal to 0, the button hasn't been pressed. Go back to the start. Don't do anything more. If it has been pressed, vending machine has a request hash function. It's that one there. So we just send it prefab, the hash number of what we've selected. Just send it to there and it should do the rest for us. So confirm that. Export it, we're all good. So now I do have in there gold and copper. We have selected gold. If I push the button, there comes our gold. And of course now there's no gold in there, it is just the copper. So if I try and do it again, we get nothing out of it. It's not until we go back to copper, I can now request the copper, and out comes the copper. So that one is a much easier way of selecting whatever it is. If you've got a full 100 items in there, just pick one and away it comes. If you've got 10 lumps of copper in there, just push the button, it'll just dispense one of them. So that's a lot better way of retrieval. As I say, the storage silo is not very good for retrieval, but very good for storage. This one's good for retrieval. So which one do I actually use? Well, I use both. As I say, if you're sorting things out, storage silos are very good for bulk storage, but very poor for retrieval. So if everything's the same, it doesn't really matter. You just pop them out one at a time. If you've got a mixed bag of things, I store my ingots in a vending machine, so I can then just request whatever ingot I want. I generally don't have 100 stacks of ingots, so it's quite manageable to fit in one vending machine. But when you can mix and match them. Right, here we are on Lulan. Now we have 5 vending machines set up with 4 silos, sorters, a hopper, our sorter computer. So what we've got here is whatever unloads, rockets, whatever you got, unloads into the hopper, goes through the sorters. It'll sort out iron into our silo, sorts out our copper, gold, silicon, and everything else. All the rares just pop into this one here. Now these are the ones we're likely to get a lot of stuff, so I have a silo in to hold any backlog if you've got a heap of stuff coming in. It's just left open and drops into the vending machine as the vending machine has spots available. Now these don't have any controls of their own. You can just vend out what you want. So this one has all sorts of stuff in there. It has a lot of gold. We have our nickel, cobalt, and whatever else in there. So that one is variable. These ones hold the common ores. Our code is almost exactly the same. So as it was retrieving from a single vending machine, Now instead of that, we're just going to use a batch command, which sends a batch command out to request from those machines, does anybody have one of these? So once again, if we request our device, we got nickel's in that last machine there, request it, and we got our blob of nickel. Cool. Any of the other ones, gold, should come out of the gold machine, but you only get one machine respond to it. So from the one chip, those couple of lines of code, well, a few lines of code to make this work, but from the couple of lines of code to actually dispatch it, I get all I want. So if you have your super secret furnace code there, which actually knows what ingots are required for that, you can actually dispense what you need pretty easily from here. One moment, I'll be back. Here we are at our super secret furnace, our new project. We have got a selector on here just to choose what sort of alloy we want to make. Now the code for this one is just this. That's all we've got. So I do have the stack programmed with all the settings and ingredients for all of the alloys. So now all I have to do, we set our vending machine prefab hash so I can call them from a batch command. We have our dial and our button. That's all that's in there. So what I do is read the dial, set our stack pointer to read the prefab hash for the alloy and displays it on the setting. When the button is pressed, once again we set our stack pointer and then we start popping out the ingredients. One, put out a batch request, wait 1 second, pop out the next one, request, wait, 4 times for the 4 ingredients of our alloy. So if we want something like stellite, which requires, where are we? Which requires stellite, silver, 2 silicon and 1 cobalt. So push the button, cobalt, silicon, and silver. Boom, we're ready to make a batch of that. I think that was a fluke. Astraloy, which is astraloy, copper, 2 steel and cobalt. Cobalt, 2 stacks of steel and 1 of copper. There we go, easy super alloy dispenser. And all of that, then what's that, 20 lines of code. Oh no, it starts up here, I lie. 25 lines of code. So that's pretty much all we've got there. That is my mass storage. So I've just used it for storing ingots, retrievals. That's all we've got there. So I suppose I can show you my code for my stack program. That's all it is. It's just a 9-part stack. It just writes your alloy, your maximum minimum temperatures, and your 4 ingredients. And it's just a big long list that just pushes everything into the stack, and that's all it is. Simple. So that's it. Super furnace and our ingot dispenser, our ingredient dispenser. So it will all go super simple, super quick, all from one chip. Easy. So till next time, happy building. See ya. Well, that went well. Hope nobody realises I haven't got a furnace.